So next up are the derivatives of trigonometric functions. And we're going to start with the derivative of y equals sine of x. Using first principles, we end up with the following expression. The limit as h approaches 0 of sine of x plus h minus sine of x all over h. Again, if we sub in 0 for h, we're going to get our indeterminate form 0 over 0. This means we should look for a method to determine this limit. So first thing we're going to use is one of our compound angle formulas. So recall that sine of a plus b is equal to sine a cos b plus cos a sine b. So now we have the limit as h approaches 0. So using our compound angle formula, we get sine of x cos of h plus cos of x sine of h, and then minus sine of x. And that's all over h. We're going to group these two terms together because they both have a sine of x and split this limit up. So this is the limit as h approaches 0. Sine of x cos of h minus sine of x all over h times the limit as h approaches 0 of cos of x sine of h all over h. In our first limit, we have a common factor of sine of x, which I can move to the front of our limit since there is no h in that term. So we have the sine of x times the limit as h approaches 0 of cos of h minus 1 all over h times, and similarly in our second limit, we can bring the cosine of x to the front of our limit notation, and then we have the limit as h approaches 0 of sine of h over h. So what we need to do is evaluate this limit. What does that equal? And what does this limit equal? And again, if I put 0 into this expression, we end up with the indeterminate form for both these limits. So for us to determine the value of these limits, we're going to use a table of values. Key thing, make sure you're in radian measure on your calculator. So we're going to start with this limit first, and we're going to test the limit as h approaches 0 from the left and as h approaches 0 from the right. So let's set up our tables. Next thing is to again make sure your calculator is in radian measure and then sub in your h values into our function cosine of h minus 1 over h. And if you do this properly, you should end up with the following numbers. And these tables tell us that the limit as h approaches 0 of the cosine of h minus 1 over h, we can see that both the left and right hand limit approaches 0. So therefore this limit approaches 0. So we know that this limit here is going to 0. So let's check this limit here. Oops, and I made a mistake here. This should be a plus sign here because we split them up into two different limits. So let's check the next limit. So we want the limit as h goes to 0 of sine of h over h. Let's set up our tables and see what happens. So again, make sure your calculator is in radian mode and you'll end up with the following numbers. And we see that the limit as h approaches 0 for sine of h over h is approaching the number 1. So if we go back to our limit over here, we see that this limit is approaching a value of 1. So what we're left with is the following. So we now see that f prime of x is equal to sine of x times 0 plus cosine of x times 1. So therefore the derivative of sine of x is equal to cosine of x. And we can go through the same process and prove the derivative of cosine of x and see that it's equal to negative sine of x. If we want the derivative of sine of x and cosine of x, instead of using first principles, we can use our shortcut. If we have a function that has sine of x in it, then the derivative of sine of x is cosine of x. If we have a function with cosine of x, its derivative is the negative of sine of x. And for homework, you should prove this one using first principles. Now that we've got these shortcuts, let's go through some examples. So first of all, y equals cosine of 3 of x. Remember, this is a composition of functions where the outer function is cosine of x, the inner function is 3x, the derivative of cosine x is negative sine of x, that's our new shortcut, and the derivative of 3 times x is equal to 3. Using the chain rule, that means we have to find f prime g of x times g prime of x. That's going to be our derivative for this function. So dy by dx is equal to, well, f prime is negative sine of x, but it's f prime of g of x is 3x, then times the derivative of g, which is 3. So therefore this is equal to negative 3 sine of 3x. Next one, notice we need the product rule. We have a function times a function. So for this example, g prime of x, so p prime q, that would be 1 times sine of x, plus pq prime, that would be x times cosine of x. So this derivative is equal to sine of x plus x times cosine of x. All right, next one, we need the chain rule again. So our outer function is sine of x this time, and our inner function is x cubed. So f prime is cosine of x, and g prime is equal to 3x squared. So f prime of x, remember that's f prime g of x, so that's going to be cosine of whatever g of x is, so that's x cubed, times the derivative of the inside, or g prime of x, that's 3x squared. So we end up with 3x squared times cosine of x cubed, and we're done. Next one is sine cubed x. That's the same thing as sine of x all cubed. So one more time, this is a composition of functions. So the outer function this time is x cubed, and the inner function is sine of x. The derivative of x cubed is 3x squared, and the derivative of sine of x is cosine of x. So we have h prime of x is equal to, so we need f prime of g of x, so that's 3 sine x all squared, times the derivative of the inside function, which is cosine x. So this is the same thing as 3 times sine squared x cosine of x. All right, next one. Again, a composition of functions. So this is dy dx equals, the outside function is e to the x, but this is a composition, so this is e to the sine of x plus cos of x, then times the derivative of the inside, or in this case the exponent, and the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. And we're done. And f. Notice we have a function divided by a function. So this time we're going to use our quotient rule. So we have f prime of x is equal to, so p prime q, so that's 8x times cosine e to the x minus pq prime, so that's 4x squared, and cosine e to the x is a composition, so that's negative sine e to the x, then times the derivative of the inside, which is e to the x. All divided by cosine e to the x all squared. And one like this, we could take one step to simplify. The only common factor I see in the numerator is 4x. So I take out a 4x, and I'm left with 2 cosine e to the x minus x e to the x, and this will become plus because of the two negatives. So this is sine e to the x. So there's our numerator, and our denominator is still cosine squared e to the x. Now let's take a look at a couple application questions. So first one, determine the equation of the tangent at x equals pi over 8 for the function sine squared of 2x. So remember, we can rewrite this as sine 2x all squared. So first of all, if we want to find the equation of the tangent, we need the slope of the tangent. So let's take our derivative for this function. We're going to need the chain rule, or the power of the function rule if you like. We need to bring the 2 to the front, and then we rewrite what we had inside the brackets. So this is sine 2x, and then this is now to the exponent of 1. Then we need to times by the derivative of the inside. The inside function is sine of 2x, and the derivative of sine is cosine of 2x. Then times the derivative of the inside of that function, which is 2. So this simplifies to 4 sine of 2x times cosine of 2x. We want the derivative at x equals pi over 8. So we want f prime of pi over 8. So that's 4 times sine of pi over 4 times cosine of pi over 4. So this is one of our special triangles. So this is our pi over 4 triangle, which gives us the following side lengths. And this tells us our slope is equal to 4 times 1 over root 2 times 1 over root 2. And if you simplify, we get a slope equal to 2. So there's our slope. Next, we need the point of tangency. So let's look at x equals pi over 8. We then want to examine our y value. Our y is just f of pi over 8, and that's our function. Our function is sine of, if we sub in pi over 8, that becomes pi over 4, all squared, which is 1 over root 2, all squared, which equals 1/2. So our point of tangency is pi over 8 and 1/2. All right, so we have our slope for our tangent line, and we have our point of tangency. So let's put these together. So we have y equals 2x plus b. We sub in our point, so that's 1/2. 2 times pi over 8 is pi over 4 plus b. So b equals 1/2 minus pi over 4. And if we want to make that one term, finding a common denominator, we get b is equal to 2 minus pi over 4. So therefore, our slope of the tangent at pi over 8 is equal to y equals 2x plus our y-intercept 2 minus pi over 4. And we're done. And our last example, determine the x values where the tangent to the curve f of x equals sine x times cos x is horizontal on the interval 0 to 2 pi. So first of all, we need the derivative. And we're going to set it equal to 0 to look for our horizontal tangents. So f prime of x, we're going to need the product rule, since we're multiplying two functions, sine x and cos x. So first of all, we need p prime q, so that's going to be cosine of x times cosine of x, then plus sine of x, so this is pq prime, times negative sine of x, the derivative of cosine. So we're left with the expression cos squared x minus sine squared x for our derivative. Next, we're going to let f prime of x equal 0. Then, that means we need to solve the following expression. Cos squared x minus sine squared x equal to 0. So I'm going to go through two different methods that you can use, and both will give you the same answer. So method 1 versus method 2. Method 1, I'm not going to use an identity. What I'm going to do is isolate for sine squared x, and that's equal to cos squared x. Then I'm going to divide both sides by cos squared, and sine squared over cos squared is tan squared, and cos squared over cos squared is 1. So now I want to solve for where tan x is equal to plus or minus 1. And this is one of our special triangles again. This is our pi over 4 triangle, opposite over adjacent, 1 over 1. So that tells us we have a related acute angle, tan inverse of 1, is equal to pi over 4. Since tan is both positive and negative, we're looking for the angle in all four quadrants. So our x here will just be our related acute angle, pi over 4. Our x here will be pi minus pi over 4. So that's going to give me 3 pi over 4. My x here is going to be pi plus pi over 4. So that is 5 pi over 4. and my x here is going to be 2 pi minus pi over 4, so that's going to be 7 pi over 4. Alright, so our four answers: pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Let's take a look at method number 2. Method number 2 is to use an identity. So for example, cos squared x minus sine squared x, that is equal to cosine 2 of x. So if we use that identity, we get cosine of 2 of x is equal to 0. And if we look at the graph of cosine, it equals 0 at the following two locations, between 0 and 2 pi. So we get that 2x is equal to pi over 2, and 2x is equal to 3 pi over 2. Dividing by 2, we get x is equal to pi over 4, one of our answers from previous. And the second one is 3 pi over 4. Next, we add the period to get all the remaining answers. So in this case, our period is pi. Remember, that's 2 pi over k. So 2 pi over 2 is equal to pi. And then our final two answers, if I add pi to x1, I get that x3 is equal to 5 pi over 4. And then x4 is equal to 7 pi over 4. So the same four answers we got using the second method. So for homework, I'd like you to prove that the derivative of cosine x is equal to negative sine of x using first principles. Use the same procedure as we did for determining the derivative of sine of x. And then from your textbook, try the following questions. And good luck.